So this next demo we'll be using our service robot. This is where we'll start to map the world in more than just 2 dimensions. So sometimes a robot needs to be able to understand what's going on in 3 dimensions. Whether it's a drone, it needs to plan its path up and under obstacles, or if we want to build something more similar to a digital twin and build that map in a way which is more understandable to a human. So this next demonstration uses exactly the same sensor. It's running on a Jetson NX. And as I start to move the robot around, you can see we're now starting to build a 3D reconstruction of the demo suite. Now as I complete the circle and start to move the robot, I can start to move the screen, and you can see this is a full 3D model of the space in which we're operating. But this is actually much more than just a 3D digital twin. We've also used our neural networks to in real time label all of the obstacles and all of the objects that the robot has encountered. So you can see there in purple the couch, the chairs in green, and actually yourself there in pink. This allows us to do things like remove the people from the map, because quite often when you're building a map, you don't want to have to clear the entire room, so this means you're able to map a space without asking everyone to leave. Maybe you want to remove the chairs and the couches so that we only have the walls and the floors visible. And this is actually what we call this third level of spatial intelligence, where we have the first is just the sparse point cloud, the second is the kind of 2D or 3D geometry, and the third is actually the semantic understanding of the space. And this is really something we're pioneering here at SLAMcore. This allows robots to behave with more intelligence when they're not just dumb machines trying to avoid obstacles that they encounter, but they actually understand the obstacles and what those objects are.